Hi, today we would be learning about the chain of responsibility principle. Again, without me telling what is chain of responsibility principle, let us understand the problem statement. So, the problem statement is that we are trying to build up a customer service. What does that customer service look like? Let's say it is a very small company as of now, okay? And I brought a phone from that company, okay? And then when I brought the phone, I saw that I am not able to use it. Like I don't know where to find up this setting. So I called up the customer care. The customer care helped me. Okay, this is what is the general trend. Now see, this is my phone. I called up the customer care and the customer care got to know that I don't know how to I needed technical help in settings. So a executive would help me. Let's say I have a grief to share, like let's say this is not working or the app is crashing then and there. Then I need a technical person to solve me. Okay. Now, if the grief is more, like let's say my phone recently my EMI number got erased up from the firmware. So now I need a person who is a manager and who can look into this priority. And now let's say my phone is not even working, not even turning on. Then I need to talk to some higher authority. So based on the severity of the issue, I should be assigned someone from the hierarchy. If the severity is high, I should be assigned from someone from the higher hierarchy. If the severity is low, I should be assigned someone from the lower hierarchy. This is what is there in the general trend. Fair enough. Same thing we are trying to implement it here. We are having a support ticket handler and we have a handle ticket which takes up a string, and it would take the priority of the string, low, medium and high, and based on that he would assign the respective person. It would take a string based on the priority. If the priority is low, the support agent would be looking into it. If the priority is medium, then the support agent is not the person who should be looking into it. He passes on it to the supervisor, and now supervisor would look into it. Then if the severity is high, the manager would look into it. Else, let's say someone just randomly called up in a wrong number and asking for some honeymoon tickets or something, then that is not the ticket that needs to be catered. So it is an invalid priority level. Fair enough. This is what we are trying to implement. Seems like this is a very good thing and very simple code and efficient code, and it would work elegantly, no problems in this code. But if you talk about the software practices like dry, that is not repeat yourself, or solid principles, then it doesn't adheres to those principles. Let's see and elaborate over those. So now see, what are the problems in here? The very first problem is open closed principle. How is that? See, let's say tomorrow a new agent comes up. Let's say that is a small company, and when even the manager is not able to solve, the CEO would come into the picture and he would hear the grievances from his customer itself. Simple thing to do, like small company, the owner of the shop comes. That is it. Simple enough. So if I want to add a new type of support agent or a new type of agent, then I need to edit this class. So this class is open for modification. But open closed principle tells us what? A class should be closed for modification. It should be only open for extension. So we are not extending it, we are modifying the class itself. Then the very next thing is the single responsibility principle. How? See, this class is handling multiple things at the same time. Let's say tomorrow something related to the support agent changes up. What can be something? Let's say tomorrow the support agent needs to fill his work log while the manager or the CEO doesn't needs to fill the work log. So I need to add one more work log to this. So then also I need to change. If let's say tomorrow the supervisor also needs to do something else, let's say he needs to look after his support agents which are reporting to him, then also the class would get changed. So this class has more than one reason to change. The number of peoples that are there would be the number of responsibilities this class have. But single responsibility principle tells us what? That a class should have only one responsibility to handle. But here we have two responsibilities. The very next thing is that it is very hard to add extra logic. What is that? As of the last example I told, if let's say support agent wants to fill the workload, then supervisor needs to look after the support agent that is there. So it would be very messed up. It would be very messed up. Like let's say support agent is passing on it to the supervisor, or let's say there is a generic logic that needs to be done. Like whenever the support agent passes it on to the supervisor, he needs to note it down how many tickets I have passed on to my supervisor. Let's say he wants to note it down. Then I needs to have a generic logic to that. And adding that generic logic or adding that extra piece of logic in an if statement is very difficult. Because altogether we are handling the own entity in there. And in real world, it won't be just system.out.println or cout or a print statement itself. It would be a FT code itself. So handling that FT code on the basis of switch statement is not the thing that sort principle prescribes. So how can we solve that? So before I move forward to how can we solve that, let us first build up an intuition for this design pattern. So see, if you observe that the problem is there, that if there is a logic, it checks that logic and directly comes up to the next checking the next logic. So problem is where? That it just checks if this condition is fulfilled or not. It doesn't do anything else. After we have done a good amount of DSA, let's have some little bit of problem solving to it. Can't we do something like this? That we have a linked list. We have a linked list kind of structure. Okay. The very first node would see if it can handle it. If it can't handle it, it would pass on to the next node which is pointing after it. Then if it can handle it, it would handle it, else it would pass on to the next node. If you observe, each node would have its own responsibility. And if I want to add logic to this node, I can simply add this and we don't need to edit anyone else. Let's say a logic of this needs to be handled, then logic of these all doesn't needs to be handled. And then all this node can be referred by abstraction or interface, so that everyone is treated the same to have polymorphism. Like a little bit of intuition. And this is indeed what chain of responsibility principle tells us. That we have kind of linked list. Whenever you think of chain of responsibility, chain means linked list, and this is how I would be doing it. Fair enough. Whenever you need to pass on from one thing to another, and in future you have the probability that there might be some extra logic, or might be someone else might be coming in between, then we don't want to change the if statement. If we want to have this. Why? Because if you observe, what did we learn while we were learning DSA? Let's just recapitulate or just link up our knowledge. So see, we learned that removal of a linked list, removal of a node in a linked list is very easy. As well as changing the pointers of a linked list is also very easy. So this is why if we have a linked list kind of structure, then removal, addition, changing the direction is a beauty in itself. Okay. I don't want to drag it more. I hope you have understood it. Comparatively a simple thing to understand. Now let us move forward to how we can do it. So see, one thing which is very simple to understand is what we did while we were implementing linked list. We had something like this. We declared something like node, and then we had data, and then we had the next node. We have the next, which is the node itself. We had this kind of thing. I'm just trying to link up things so that you would be able to retain this for a longer period of time. Okay. So now see, here we don't have something like data. So I would be removing this data and I would be writing execution, because everyone would execute itself. Fair enough. You can write post execution, pre execution to have logics before it or after it. That's your job. Now see, next would be of the node itself, and this would be same for everyone. So that is why instead this is not interface, because I would have non-abstract methods. So to have non-abstract methods, what I would do is I would instead implement an abstract class. And here, every abstract class would hold a reference for its next node. I'm talking about next node, but in the real world, in terms of chain of responsibility, we call it handlers. So use handlers and nodes interchangeably. I would use it interchangeably so that you have the foundation also, but you know the technical terms of this also. Okay, fair enough. So every support handler would have a link to its next handler. Make sense? Then we have a method to set the next handler, and this would be non-abstract, and handle request would be implemented by each one of them. Good enough. Now see. See, every support agent would just implement handle request, handle request, handle request. Now if I want to change some logic of supervisor, I can just change up this. If I want to add up a new person, I can just add up this person and have it implement support handler and write a method known as handle request. I don't need to change the class. So this class is not there for modification. This is only open for extension. Just handling up things is perfect enough. Now let us see what would be the effect of client also. Now the client would set who would be the next handler of whom. So anyone who is using my modules, I would give them that this are the person who can handle request. Now the client can decide whoever wants to do it in what hierarchy. Let's see that in action. Concrete implementation is always necessary. We have a class, this is the client class. So I have a new support agent, supervisor and manager. And then see, support agent, I can set next handler. I can just call the method of next handler. Now support agent's next handler is supervisor, and supervisor next handler is manager. As every one of them is implementing that, so it would be polymorphism. So no worries. Okay. So now if I pass on a request according to the issues, it would just pass it on. Okay. Now see what needs to be done. So see, support handler. Okay. This is the abstract class I have shown. Support handler would do what? Whenever you give a next handler, it would take something of the data type support handler. That just means anyone who implements this, it can accept it. So now it would set it. Handle request is abstract, and people who are implementing this or extending this, they needs to implement it. Now override handle request, and it would say if the priority is low, I would handle it. If the priority is not low, then I would search if the next handler is present. If yes, I would pass it on. So what is this code? I would tell you what is this code. See, this code is just like if heads next is not equal to null, then head is equal to head dot next. We wrote this code when we were solving linked list back then, when in our interview days. The same thing is here. We are first checking if its next handler is not null. If it is not null, then we are passing it on. If that is the last node, then that is the tail node, we would be stopping at that. It won't be processing this if statement. Then see, if it is a medium, then it would handle it itself. If it is not medium, then it would go on to this. Again, check if there is some node after that or not, and it would pass. And this is also there in the system. Chain of responsibility principle is nothing but using a linked list kind of structure to handle things and to segregate things, so that each node would have the responsibility of its own, and each node can do it in own ways. So now we have open close principle. Each support agent has its own duty to attain. We can add elegantly extra logic. Now this support handler or everyone, we don't need to change the support handler to, we can just extend the class and the client can call it by that. So all the remaining class or the previous classes are closed for modification. Now the only con is that This is a very good, not over engineering kind of stuff, a very good practical design pattern. Now, one important thing is that if you observe that this is a linked list kind of structure, okay, if anyone processes it, then it does not passes it on to the next node. This is what happens, no? If it is not of that priority, if you observe, if it is not of his own concerning priority, then he would pass it on. It's not that he would handle it and then pass it on. It might be a scenario that some of the requests end up unhandled by the designated person because someone on the lower hierarchy just returned it. Now, you would be wondering that this customer service example fits well, like it gels up enough with the chain of responsibility principle, but the applications of it in real life. Okay, so let me tell you, this has a lot of applications in real life. Okay, so now I would be talking a bit high level. If you have done a good amount of development, then you would understand it. So see, this is the client. He hits up the load balancer, and the load balancer hits up the servers, and the servers, it might be a scenario that there is some page which I want, like buy now page should only be shown who have already logged in. So now people who are logged in, then only I would show that buy now page. If you observe that at any point if the request fails, I want it to return. Okay, so I won't be doing that in case of if statement. So I would be using chain of responsibility. Load balancers like Nginx can be used. Then this is the server. Then we can have some authentication class which we can see, which would just tell if the admin is not, admin is able to see all pages, admin is able to have all responsibilities. So based on that we can assign roles. So assigning roles, level thing, admin management, login and non-logged in. So it is used in the industries mostly where we build REST APIs because that gels up enough. Okay, so that was it from my side. I hope you understood this. If not, let me know in the comments what needs to be done. Thank you. Goodbye.